Today, it's fun. We're actually going to talk exactly about that. We're going to talk about how important it is. And I want to show also, we're going to do two things today. We're going to talk a little bit about the industry and kind of where things are going in technology as a whole around IoT and embedded. And then we're also going to show you some hands-on, ground truth around actually building some of this stuff with our platform, with Meadow. So today when we jump into the code, we're actually going to look at this. So this is a weather station we built with Meadow, and it actually connects to an open weather API and uses just regular .NET to serialize and pull stuff down, or deserialize, pull stuff down and display on a display. And we're going to show you some graphics code and stuff there. And what's cool about this is, this is the on.NET show, and you'll get to use all your existing .NET skills. So we're definitely going to jump in. We're going to talk about that. But first, I want to talk about, as you said, this revolution or this new epic, right? So IoT is really the new epic. And if you look at the story of humankind's technological process, as you mentioned, we started with these computers they took up entire rooms. We had these mainframes, and then we shrunk them down, and all of a sudden you had desktop computing, and that was big, and Windows changed the world. And then, of course, the web came along, and everyone was building web apps and cloud stuff. And then mobile hit, and we had this just amazing hero experience. And Steve Jobs stood on stage, and he was like flicking around on this little black screen, and it was just like, oh my gosh, this is the future, right? And IoT is really interesting because it's way bigger than mobile already, and yet it doesn't have a hero experience. So it's kind of the quiet revolution. It's all happening around us, and it's happening in a big way. In fact, today, IoT is already 3 times as big as the mobile app market in terms of spend. And what's interesting is that in just a few years, there will be 10 times as many non-mobile connected devices on the planet as human beings. 10 times as many. One for every human being, there'll be 10 connected things. And that is just so hard to fathom. And I remember 10 or 11 years ago, I used to go around and I would advocate for Xamarin, and I say, look, folks, and I would go to colleges and I say, if you're not paying attention to mobile, you're not paying attention, because this is going to be the thing that we're going to talk about for the next 10 years. And here I am now, and I'm saying, look, if you're not paying attention to IoT embedded, you're not paying attention, because this is the thing that we're going to talk about for the next 10 years. And it's really going to change our lives radically. We went from this idea of putting a computer on every desk in every home. This was Bill Gates' vision back in the 80s or 70s. And we really gone from that to being able to put a computer in everything, everywhere. And that will spur a really radical shift in how we interact with the world, because the interactive world is coming. And to understand this, to understand the impact of this, or have like sort of just a vague notion, think about life before and after Google Maps. Right. My wife is of a generation in which she can't even navigate without Google Maps, right? Like, what will IoT do? How will IoT change our lives in the same, in just as big of ways? And so that's really interesting to think about. And like you mentioned, while the revolution is here, you may barely notice, because we don't have a big hero experience. It's happening all around us. And I think that right now, because we're at the beginning of the revolution, there's so much opportunity. There's no better time to start learning how to build this stuff and how to, first, let's start with like, what is embedded? So today I'm going to just a couple minutes on kind of like what embedded hardware is, what IoT is and stuff. Because if we look at the scope, if we look at the continuum of IoT projects or solutions that we're seeing out there, about 95% of them are all in embedded. And what that means is microcontroller based. And we'll talk about what that is. And then there's a little bit of maybe 5% up in the upper end of IoT that are kind of like kiosk, Raspberry Pi stuff. But for the most part, we're talking about embedded solutions. And this is a different world. If you've been working in web or mobile or desktop computing for a long time, it's a very different world. And this epoch, this epic, this revolution is brought to you by microcontrollers. And this is really fascinating because because the mobile revolution gave us embedded. The mobile revolution gave us this really fantastic hardware. Now there's everything. There's sensors and peripherals, displays, everything's small. They're commodity cheap. They're reliable. They're low energy. But one of the biggest jumps that has happened here is in the microcontroller space because of a lot of the advancements that came with advancements in chip technology and being able to scale down wafers and things like that. And so now what we have is this we're in this time in which microcontrollers are incredibly powerful and can do all sorts of things. So what is a microcontroller, right? I'm talking about this. Well, a microcontroller is an interesting thing because it's basically a computer on a single chip. And it's not just that. It's not just a computer on a chip. It's also a chip or a computer that is designed to run hardware, to interact with hardware, to drive motors, to listen to sensors, to have other inputs than digital, have analog inputs, to have lots of protocol stuff, I2C and serial and all those things. So it's a computer on a chip, but it's also really, really about hardware. And interestingly enough, the first microcontroller came out in 1971. It was the Intel 4004, and it was the first time in which basically all of the things that were on a motherboard were squished down into a single chip. And it wasn't just that; it also had hardware I/O. And the interesting thing about a microcontroller is that it's a different class of computing than what we're probably used to. It's not a CPU like you would find in your PC. It's not an app processor like you would find in a Raspberry Pi or Azure Sphere or any of those other single board computers. It's really something different. It's something that's even further down in terms of classes of compute. And they are everywhere. 30 billion of them were shipped last year, and there are trillions of them in existence. And what's interesting is that by the numbers, microcontrollers today are the dominant form of computing on the planet. There's more microcontrollers than there are any other kind of class of computing out there. And the litmus test for, what is a microcontroller? Well, the thing to think about with microcontroller is that they don't run full operating systems. They're basically a very tiny chip that runs a micro RTOS, or micro real-time operating system, in which your operating system is measured in kilobytes rather than megabytes. And there's no concept of like multiple users logging in, multiple apps. It's just it's enough operating system to service a single app and provide services and access to hardware and other things that you need for your app to run. It's a very different class of computing than I think a lot of us are used to if we're, having been in the .NET world. The other thing that's interesting.
I think that's an interesting thing, because I wanted to stop there and kind of dwell on that point, because I know a lot of folks that I speak with, when we talk about IoT in general, they're like, oh, Raspberry Pi. Right? Like that's like the immediate association for a lot of folks. But now what we're talking about is, so I'm guessing it's still a yes. It's not like exclusion Raspberry Pi type devices, but you're saying that there's another class that goes on to even lower level. And I'm guessing like those types of applications are usually written with low level languages, right? Like C and
that's right. Yeah,
assembly language and those types of things, right? But now we're going to be able to do those things with a little bit more powerful tools and those types of things. But I'm guessing you'll get to that as we go on.
Yeah, that's right. So it really is a different class of computing. Raspberry Pi is an awesome single board computer, but it's not really embedded, and it doesn't cover the IoT use cases very well. When you look at like actual cost of deployment, actual cost of running, and the amount of components it needs and the size of it and whatnot, it doesn't compare to embedded microcontrollers. It's just a different class. And in fact, to that point, if you look at microcontrollers, these things consume 1,000th of the energy of something like a Raspberry Pi, which means that you can literally run them anywhere. You can run them on a small battery and put them out in the field, and they can run for years. You can put them on a little solar panel and they can run forever. You can do energy harvesting and drive them that way. And so they really are the computing everywhere chip. And they're also very, very small. Our SMT module, which is what we intend for folks to deploy in large scale production out in the field, is very tiny. It's an inch by an inch square. It's just this little tiny thing, and that's possible because we're talking about embedded chips, not really a single board computer.
Right.
So it's, it is just it's a different space. And as I mentioned, what's interesting about this is that it was the mobile revolution that actually made the embedded EPIC possible. And so today we're going to talk about our play in that space, or in the embedded space, which is Meadow. And what Meadow enables you to do is run full .NET applications on an embedded processor, on a microcontroller. And if you look at the board that we're going to talk about today, this is the F7 micro development board, and it's very small. It's in the Adafruit Feather form factor, so it's about the size of my thumb, and this is really fascinating to me. This is basically the computing equivalent of a Pentium. So of a Pentium processor, but it also has a bunch of really cool hardware I/O on it. So all the protocols that you need to connect to various hardware peripherals and whatnot, as well as analog input for sensors and things like that. It also is it's based on an incredibly powerful microcontroller that has really pretty surprising and cool features. And again, this is the edge of computing here. We're the tip of the spear in terms of state of the art. It's got 2D graphics acceleration, JPEG encoding built in, hardware accelerated encryption. So it's really a great little device. And the great thing about developing with Meadow is that you can go from prototype to production on the same hardware and the same code, because you're already building for embedded. And what's interesting today is that for professional embedded developers, when you're building embedded applications today, IoT solutions, most projects, and I would say greater than 80% of projects today, are actually built twice. First, what happens is that folks prototype on an up-level platform like a Raspberry Pi or another single board computer where you have full Linux and you have all of your application goodies and you have all your modern development tooling and whatnot. And then when you're ready to go to production, if you move past like small run batches, then typically those things are rewritten and rebuilt, redesigned on embedded hardware for microcontrollers. And so with Meadow, we cut that out all, just from the beginning. You don't have to build twice. You really can go to production with the same code, same hardware. And in your development cycle, you get all of the up-level stuff that we love. You can use Visual Studio, you can use .NET, you can use all of the nice NuGet packages that you want, system.text.json, all of the great stuff. And so that's really a major shift actually in the industry in terms of what you can do on a microcontroller. So, but don't take my word for it. We have Jorge here, and he is going to actually show us it in action.
Awesome, that sounds cool. Jorge, I'll go ahead and put your screen on, so you can go ahead and share Visual Studio and show us what's going on.
Yeah. All right. Thank you, Brian. Thanks, Cecil. So yeah, I'm going to show you something really cool that I built this week. This week, it took me maybe like a couple hours, maybe. But this is something really nice. It's about using Meadow, connecting it to your local network, and getting weather information over a public web service API, which in this case is Open Weather Map. And I just want to show you, this is the board that I have running here. So basically I have a little display here, and we're using a graphics library built in-house and to write up all the UI. And we also have this little thing, looks like a transistor, but it's actually an analog temperature sensor. So that one will give me the temperature inside the room. I built this, I ran this app around 1 in the afternoon. I'm going to run it right now so I can... So as it's run, I can show you what I have here on the logic. Let me, sorry, 1 second. Where is my, oh, here I am. Okay, sorry. So this is the project. It's called Wi-Fi Weather. And Wi-Fi Weather is it runs basically. This application consists of a Meadow app application, is the first main application, main class that it does the whole execution of the app. And you'll notice here it'll consist of two big methods. We have initialize, and initialize basically is just wire up all your hardware components that are on your Meadow board, and then once you have all the objects set up, that's it. You don't have to deal anymore with anything of the hardware. Just use your objects with a very high level APIs that we provide. And all this is because of a big software stack or a big platform we call Meadow Foundation. So Meadow Foundation is a huge library of drivers that we've been building. It's also open source. And what we do is we create drivers for each component, and then we expose a very high-level API. So the users are more focused on building their projects rather than looking onto data sheets on different components and trying to put them together to get them to work. So what we have here is an onboard LED. As you can see, that little LED glowing here, it's actually a red, green, blue LED, and we just tell it, the way we instantiate it is showing which pins it is connected, which in this case, we expose them as the onboard LED red, green, and blue. And now that's it. We can do onboard LED.start pulse, and then we can pass in a color so it has this pulsing animation. Pretty cool. So I'm not going to go super detailed here, but I just wanted to give you like a little overview of how everything is put together. So the initialize, again, we're just basically putting all the hardware together. We have the analog temperature sensor, and this is the way that we initialize it. We specify on which pin is connected, obviously. And we have a display controller, and display controller is like an abstraction to put both the display and the graphics together. So here in the weather, oh, sorry, I'm missing one class here. Let me open it real quick. Here we go. Yeah, so on weather view, we can have another method, another big method is initialized, and this is the same code as I've been showing in Meadow Foundation. We just initialize the peripherals, specifying which pins are connected, and then we're ready to go. So this is the ST7789. It comes in the Meadow hack kit. And we pass in the graphics library, the object of the display. So now we can use the graphics library, which is a display agnostic. You can use that graphic library in any display that we have available in our platform. And now we can start using graphics library to start drawing things. We have a method called draw text. We have draw rectangle. We have display JPEG to show the little icon of the weather, and that's all there is to it in this class. If we have the weather view model, for example, I am just exposing all the fields that I want to show on my display, which in this case are only the date, time, the weather code. With the weather code, that you determine which icon are you going to show, the outdoor temperature and the indoor temperature. Pretty simple stuff. And in terms of the weather service or connectivity, we just use HTTP client, something that you've used in your standalone applications, you've used in Xamarin Forms apps or any mobile apps using .NET. We use HTTP client. We do get async right here. We pass in, of course, the URI for the open weather map. There's an API there. You have to sign up, and they'll give you an API key, and you can also pass in the city as a parameter to get the weather on your neighborhood. And that's it. You do a get async, and you get the response, and you can now use system.text.json, which is very cool. We can also deserialize using JSON in existing NuGet packages.
That looks really, really interesting. And so what I want to do, so before you move on, because this is really, really cool, I think, I want to highlight a comment really quickly from Twitch from this person called Absolute Unit, and they're saying, "Hey, I'm using C right now, to write code for controllers as a hobby. He says, I'm a .NET dev. But he's definitely going to try it with C#. So, folks are already starting to see the value there. And then as you're showing this code right now, I'm thinking, this doesn't look any different to code that I usually write, right? So I've written Xamarin applications before. I've written ASP.NET applications before. And the flow of the code looks pretty normal to me, right? It doesn't look like I have to do anything outside of my wheelhouse. I mean, obviously I need to understand, I'm guessing, like the pins and the boards and the things that I'm talking to, which, is expected. But other than that, like the type of code that I'm writing looks fairly familiar, right? Which I think is a huge benefit to what we're showing here. Yeah,
absolutely. Like the drivers are really something that it makes things really more easily to show things like controlling the display, for example. We have to create what we call an SPI bus. And then if you look at the data sheets, you see all the different instructions and all the complexity to get it to work. But now we just expose all these components, separates, and NuGet packages. You just go and you just look in through a NuGet galleries and you add the components that you want. And that's it. You just need to specify on which pins is connected, obviously. But that's it. It's after the rest is history. You just focus on getting your project going rather than just fuzzling around with data sheets to get them to work.
Which is cool. So
that's right. As we were building this, the first step was, okay, let's get .NET running on real embedded hardware, right? And so we did that via Mono, and that was like the first step of this. But we didn't. As we started building this, we realized there was this opportunity beyond this, which was, look, when you're building a piece of IoT or IoT solution, if you're building today in traditional platforms, you have to go out and you have to find drivers, and then the driver may not work on your operating system. You have to fight with CMake to get it building even into your system, and then it may not work the way you want it. You have to, it's maybe not the highest quality, et cetera. So what we did is we sat down and we said, okay, look, we need to do a couple things. First of all, we need to rethink hardware APIs generally. There's a lot of ways that things work today because some electrical engineer back in 1978 said this is the way that because they coded it to the hardware and they said, okay, well, this will get this working. And 30, 40 years later, we're still using the exact same APIs. So we really rethought hardware APIs. And then on top of that, Jorge's talking about Meadow Foundation. This is this massive driver library. So you can go to SparkFun or you go to Adafruit or you buy a hack kit and you plug things in. And the great thing about it is that they just work. They just work. And there's a beautiful, consistent API. And there's modern patterns around them. You can use eventing or you can use reactive observables. You can, it's really a beautiful and different way of attacking embedded. So it's not just that it's .NET, which is really fantastic. It's also that it's just embedded better.
Yeah. And you'd mentioned earlier talking a little bit about the IoT marketplace. And I know when you're talking about the marketplace, you're probably talking a little bit more about the commercial space. But in my head, the first thing I thought when you said marketplace was, what does the ecosystem kind of feel like, both from a .NET perspective and also from a peripherals perspective? And kind of like what Jorge was saying, even though I'm running this in, I want to say, a place that .NET usually doesn't run historically, I could still use my NuGet packages because, we have .NET Standard and .NET is open source and it runs different places. So I could just pull in a NuGet package and I don't have to think twice about it. I mean, unless you're trying to do some desktop stuff, but you probably wouldn't be doing that in this context anyway. But for the most part, my NuGet packages should just work. And then on the other side, like you mentioned, we can go to Adafruit or we could go, some vendor X and pull in peripherals and attach them to our breadboard like this. And now our .NET code could just talk to it without having to know specifics about what vendor created this particular device or whatever the case is. I can just communicate over the wire via, some standard port. And again, my code just works, right?
Yeah. Also, it's very important also be mindful. This is an embedded device. So it's not like you can just grab a Unity project and run it there. I mean, it has its hardware capabilities, right? So we have to be mindful of which NuGet packages. We have to make sure that they're also very lightweight so they won't take up all of our resources on the board. So,
Yeah. But we do target, .NET Standard 1.6, and we run .NET Framework 4.7.2 right now. And we're in the works to support, Core, .NET 5, whatever the naming winds up as, right? But the idea here is that, like you said, you go and grab a NuGet package, and most stuff should just work. And case in point on the drivers, if you want to share my screen real fast, I'll show you something that's really cool. Is that if you go to our doc site, which is developer.wildernesslabs.co, and you go to Meadow Foundation here, and you click on peripheral driver library, you'll see that there are just a pile of drivers in here for all kinds of different things, from sensors, atmospheric sensors, light sensors, soil moisture sensors, etc. And if you go into these, what's really awesome is that you click on one of these and you'll see it's super easy. Here's API docs, but here's how to wire it up. So literally, you can get this. Comes from SparkFun. You can tell by the red the red box and the gear, or in the flame. This is SparkFun, and this is how you hook it up. Super easy. And so the idea here is that we really do make this. Easy. In our TFT SPI library, we've got a pile of different displays, and this is the one that comes with a hack kit. This is what Jorge is showing. So it really is just, plug it in, follow the Lego instructions, and you have an API.
Nice. That's awesome.
Yeah. And also very important is that Meta Foundation is open source. So if you we're also welcoming contributions from other individuals, other developers, that they have other cool peripherals that they're porting, and they can do submit pull requests. We review them, and we can, of course, include them in our repo. So, yeah.
Cool. That sounds great. So really quickly, I just want to acknowledge some folks in the chat, and we did have one question that I wanted us to acknowledge. So first, I want to give a shout out to my buddy Cam Super. So Cam works on our docs team, and he was just saying he just wrote some docs, so docs.microsoft.com/.net/IoT. So, again, if folks are interested in taking a look at that and learning a little bit more about .NET and IoT, you can check that out. Also, we have an episode on .NET on our channel about Bots Barbecue and .NET Core, which is cool, where we have some folks, Cam is showing how he can grill ribs. And I haven't tasted the ribs. I heard they're pretty good, but he grills ribs with his IoT device, and so that's super cool. Now, where's the other one that I was looking for? Another person was asking. So this person is he's watching us on YouTube. He's asking, what are the limitations? I'm guessing they're asking, what are the limitations for Meadow? Or maybe they're talking about the board too. Or maybe y'all can answer both. I guess you can let me know.
Yeah, so when you're doing Meadow applications, it's important to know that you are designing for an embedded device. But we've made a pretty beefy device. It's got 32 megabytes of RAM. It's got 32 megabytes of flash on there, and so you can think of that as a hard drive that's non-volatile storage. And of that, I think about 26 megabytes is available for user code. We have some of it is reserved for the operating system, and then we have like kind of a double bank thing, so we can do over-the-air updates and whatnot. So it's actually a pretty beefy device. And you can do things like graphics. You can drive small displays, and you can do touchscreen stuff. And in the future, we still have optimizations to make there. With that said, so some things are a little slow, but we're getting faster all the time, and we're working on AOT right now. So right now we're running mono with the interpreter going, but still pretty fast and performant. But when we get AOT on there, we'll get about a 10x boost on there. And so it's, there are, like I said, there are limitations. There are things that, you wouldn't try to build a Windows or a WPF app on this. But in terms of like IoT scenarios or use cases, there's really hardly anything that you can't tackle with a Meadow device.
Something that I would like to complete that is something really, really handy on the board. It comes with Wi-Fi built in, and also Bluetooth. So the connectivity capabilities, it's already on the board. You get a board, you already can hook it up to your local network, and you can start connecting to things on the internet, and without trying to get a Wi-Fi shield and another other boards. So I think it's also pretty good.
Okay. Here's another question. This one's coming in from Twitch. This one's asking, can you debug the code on Visual Studio? So I'm going to guess that's a yes, because you're showing Visual Studio a little while ago. But
so today we have console.writeline. We're actually working on debugging, on plugging that into the IDE right now. It's mostly done. It's a matter of now. In fact, we get a lot of that from Mono, and then we've wired it up through our operating system underneath. So it actually, everything's coming over USB. And now we have the wire up on the IDE. So making sure that the IDE connects on it, creates a debug session, and it's talking all the right things. So we're working on that right now.
Okay.
And you'll be able to do step-by-step, just like you would in any other .NET application. Set a breakpoint, do step-by-step debugging, have like and in fact, you're even able to do the immediate window and do kind of the REPL thing, because it's full .NET. You know, you can emit code and you can run code and stuff.
Now we have one question. I was going to ask this later, but looks like our users got to it before I did. But I think it's something important for us to discuss. And Daniel on YouTube is asking, is there a security aspect to this thing, especially if it's connected? I'm guessing when it says to this thing, not just Meadow, but I think it'll be interesting to talk about security for IoT in general. Like, what does that look like? And also, what are some of the things that we should think about when it comes to securing like a multitude of devices spread across like our infrastructure?
Yeah, that's right. You know, so, and that's a really good question, because if you look at IoT in general today, you'll see that IoT, you know, security in IoT is largely an afterthought, right? I've seen just about everything out there hacked. And we've thought about security from ground up. And so we're actually working on a security stack that'll launch in a couple of releases away, which will add a bunch of stuff. But things that we're working on are things like secure encrypted firmware boot. So when you deploy an application, it will be encrypted, and it will only boot from your firmware if that firmware matches the key, the encryption matches the key that's burnt into the chip, you know, and we'll provision these devices with a key, and we'll rotate key, you know, we'll change out keys ever so often. And so we're thinking about it from firmware standpoint all the way up. And in the stack, you know, .NET has a lot of security that you get for free, because you're not ever going to have a buffer overrun. You know, that's one of the things in like C code that is the most common vector for code attacks is buffer overrun. Well, you know, we don't really think about that in .NET. You know, arrays have bounds, and if you try to walk outside of that bounds, you're gonna, you know, it's gonna get an exception. It's not gonna poke into the kernel and give you some weird stuff, right? And then we're working on secure over-the-air updates. So the idea here is that you'll be able to push security updates. You'll be able to push a new OS and a new application securely over the cloud, and it'll be a reliable upgrade. And we're working on components. So that if you want to do things like have an easy way to set username and password if you deploy a device and to your users and you want them to run through and run, set username and password, then we'll deploy a component where, look, all you have to do is deploy this component. It'll automatically put the web server on there, set the Bluetooth mode up appropriately, set up it as an access point and Wi-Fi or whatever, and then run through, you know, and give you hooks so you can customize how that's serviced or how that's served to the user. And then also in education, we've been thinking about, like, you know, in terms of making IoT devices secure, what are the things that you actually need to think about? So we will absolutely, you know, we'll have a lot of education and content around that as well. So we've been thinking about security from like top to bottom. There's also something that a partner of ours has integrated, which is if you really need defense grade security, and this is for like our customers that are in critical infrastructure and in energy and whatnot, there's actually enterprise fast blockchain integration built in for Meadow, where you can do secure sourceless identity. You can do Merkle tree validation for messaging, so you can have a network, like a self-organizing network of devices, and they can talk to each other securely in a way that, you know, messages can't be tampered with. And if a message is missing from the stream, we know. So there's a ton of security that is both built in and stuff that you can add on and you know, that we've been thinking about.
Nice, nice. We have a ton of questions coming in, but let me let you all go ahead and continue with your presentation, and then we'll get back to some of these other questions in a little bit. So Jorge, did you want me to go back to your screen, or
no? Bryan, you can continue.
Oh, all right, you done? Did you finish showing what you wanted to show?
I just showed. Yeah, I think it was the weather. The weather is what I was planning on showing today. So
cool. All right. Well, yeah. Let's. So maybe this is a good time to start. Maybe this is a good time to learn how to talk. Maybe this is a good time to talk about how to get started. Right. So this is pretty awesome, and we definitely want you to be enabled to build IoT. A couple of things. First is that a caveat to all this is that Meadow is still in beta. So we are, this is a project in flight, and we're approaching V1.0, but we're not there yet. So there are some things that are missing that we're working on. So HTTP server, we actually have HTTP client working just fine. So you can call up to servers and get data back and whatnot. But if you want to run a web server on the Meadow, we're working on HTTP server right now. And I just learned this morning that we have all the low-level sockets up to support that. So now we're just working on wire up there. And SSL isn't in place yet. We've got it built in, but we're working on some wire up there. And our Bluetooth API is in progress, is in flight right now. And then I mentioned debugging. And then there's just other stabilization issues. We might run into weird stuff with the garbage collector, or, if you try to, we ran into a bug the other day where if you wanted to do reflection emit, and then it threw an exception within that emitted code, then that exception went nowhere. And we that's kind of like weird bugs like that we're stabilizing and whatnot. But if you do want to get started with this, you want to jump in, it is a good time. We are running a $10 off hack kit deal for Cyber Monday. And I think this expires today. So if you want to buy one and get $10 off, definitely do that right now. We'll put the link in the chat and whatnot. But yeah, so go grab a hack kit. All of what Jorge showed today is buildable with a hack kit. And in fact, there are piles of projects that we've put up on Hackster. So there's a ton of projects here that are really awesome. And 90% of these projects can be built with a hack kit today. So we definitely recommend, getting a hack kit and just starting to build, just go for it. Just absolutely just go build.
Nice. So Bryan, one of the things I'm always curious about whenever I see platforms like this, do you have any really interesting customer stories that you could share about some of the things that you might have seen folks build with it, outside of these hack projects, any real world applications that you might think are interesting?
Yeah, absolutely. In fact, we have a couple of customers. Our first production deployments are going out this spring, and I can kind of talk about some of them I can't talk about, but people are building things that are interesting and across the entire spectrum. So we've got folks building smart. So in the industrial IoT sector, we've got smart folks building energy meters. So these are little devices that would attach to industrial machinery and monitor energy uses within on a factory floor. And that's actually a big customer of ours that is deploying this spring. We have people doing smart windows and smart building stuff. So windows that automatically open and close based on your home automation system and know when it's raining and automatically close. We have people are building, we had a customer building home health, like a telehealth home kit. So you could get, a doctor at home or nurses can go and visit folks and have a small pack of IoT enabled health devices. We've got this is really interesting. Elon Road is an interesting project in Sweden where they're electrifying the roadway. Instead of having overhead electricity lines, they're actually putting an inductive strip in the roadway and being able to charge not just your car, but also transit and stuff. And they are using Meadow in the controllers there. We have people building GPS tracking. That's an interesting, that's like a great use case, because let's consider like logistics, right? If you wanted to build a solution that maybe you put something on the side of a container that communicated with some sensors on the inside, and then you could walk up to it and scan the QR code with your phone, and then that connects to a web server on the device, which then gives you the manifest. That's a great use case. So like simplifying logistics. We have a customer that is building a nuclear reactor. They actually have some sensors that can measure different types of radiation and stuff happening within a nuclear reactor. So it's really all over the place what people are building. It's really, it's cool to see.
Nice. That's awesome. Now, looking in the chat here really quickly, again, we have tons of questions. I'm going to try and make sure I get to everyone, so they all have a chance to get their questions answered. This one's coming in from YouTube, and we've actually seen this particular question asked a few times, both in YouTube and Twitch. But I guess the general gist is, for Meadow, does it only run on the Wilderness Labs hardware, or is it an open hardware model? Can I run it anywhere, or do I have to get your chips to do it?
Yeah, so today we run only on our modules, and we're going to expand sort of up and down the use case spectrum. One of the things that we're going to do is we're going to get Meadow running on like an ESP32 only module. So for like the low end, if let's say you're building industrial automation around ag tech, and you need a sprinkler system, and you have like maybe thousands of sprinkler heads around, and you want to put like little ESP32 based Meadow boards, then you'll be able to do that. You'll be able to run it on an ESP32. So down at that, down at the lower end of the spectrum. But ultimately, you'll have to run it on Meadow blessed circuits. So we'll run really well on a set of different use cases, and you can either buy those from us, or you'll be able to license that into your own circuits if you want to go out to scale. But yeah, those are coming in the future, and we'll open source our hardware designs. We need to make sure that they come with appropriate documentation and stuff, so that if you want to actually go spin a Meadow circuit board, then you're not left hanging with a bunch of questions like, well, how does power work, and what chipsets do I need and stuff. We really want to make sure that those are all well documented.
Okay, cool. And there's also some folks that are curious about what's on the board. Like this particular person is asking about a GPS. I know prior you mentioned there was Bluetooth and there was Wi-Fi. Like what other things are on the board that we could, out of the box that we could play with?
Yeah, so the board out of the box has, it's got an STM32F7 main microcontroller, and then it's got an ESP32, which provides Bluetooth and Wi-Fi, and it's Adafruit Feather form factor. So it also has integrated LiPo or lithium ion charger. So it's pretty cool. You can plug a battery straight into the board, and then hook up solar or something. Like this is a little GPS tracker that I've been building, and you can plug in solar at the bottom and then plug in a battery, and then all that's taken care of by the board. I know there's a question, is there GPS inside? There isn't a built-in GPS receiver, but you can add an Adafruit Featherwing for GPS, and we have drivers for that, or you can add any other industry standard GPS modules and get up and running. So you can do just about anything you want.
Great. And Fee Okomo, this person's on Twitch, and they're asking, so is there some type of micro OS running on the microcontroller? And there's some documentation about the architecture. I feel like you answered this a little bit, but maybe you can expand upon that a little.
Sure, yeah. So basically our stack looks something like this. At the very bottom, we have NutX, and NutX is a real-time micro RTOS, micro operating system. And we've customized that pretty extensively. And on top of that is Mono, which enables us to run .NET. And we've done a lot of work to make that work, together with the operating system, and to expose the things that we need in terms of hardware. And then on top of that, there's a thing called Meadow.core, and Meadow.core is our hardware API. So when you want to instantiate like a digital output port or an analog input port, or you want to talk over I2C and create an I2C bus, that all happens through the Meadow Core API. And then on top of that is Meadow Foundation, which is the drivers and whatnot. So yeah, there is a micro RTOS. It's a full stack. And we're working on cloud right now, which will allow you to do secure over-the-air updates and, like data visualization and device health management and push messaging. So you can actually do reliable messaging to the device as well as get data back and whatnot.
Right.